Recording of another problem. This one here, 1389. There's another one similar to it, or based on the same figure. So let's see, 1389. The boy of mass 40 kilograms is sliding down a spiral slide at a constant speed such that his position measured from the top of the chute has components r 0.5 meters, and that's constant. Theta changes with time, like 0.7 t in radians, and z also changes with time linearly, negative 0.5 t. T's time, it is in second. Determine the components of the forces which the slide exerts upon him at the instant t equals 2 seconds. Neglect the size of the boy. So I have here the a drawing, and the boy is this sphere here, and there will be gravity acting. So this is m times g, and then there will be the reaction from the slide, which essentially make the boy move on the spiral trajectory. Okay, so we have a radial direction. We have the direction of theta. So radial direction UR, and this is U theta, and then UZ is up. Okay, up because z-axis is positive up, so this is UZ. So we're going to state the equations of motion as sum of forces in the r radial direction equals mass times acceleration of radial direction. Sum of forces in the transverse direction is mass times acceleration in the transverse direction, and sum of forces in the z direction is mass times acceleration in the z direction. So we need to evaluate all these accelerations. The normal, or rather the reaction from the slide in the vertical direction is going to so for radial and transverse directions is just the reactions from the guide, and then in the z direction there's reaction from the guide, and then we have opposing, so reaction from the guide is up in this direction, and then we have weight of the ball. Okay, so we need to calculate, let's take care of the right hand side and calculate AR. We know the equation, so R double dot minus R theta dot squared. Since R is constant, first and second derivative will be 0, so I have negative. And just, so what t equals, so calculate the reactions. At t equals, we said 2 seconds. 2 seconds. Okay, part of the problem statement. So at some point we'll need to calculate the derivatives of theta. And so first time derivative of theta, it's 0.7. So we have R 1.5, that's constant, negative r times theta dot is going to just be 0.7, and this goes squared. Acceleration in the transverse direction is r times theta double dot plus 2r dot theta dot, and so this was 0, this is now equal to 0, so it's going to be 1.5 times, let's see, we had theta dot 0.7, actually a in the transverse direction is just all going to be 0. All 0. Why is that? Because never put this explicitly on paper. So theta dot is going to be 0.7, and theta double dot is just going to be 0. Derivative of a constant 0. So this is 0. This is a constant, so 0, and then r dot is 0, and the whole thing is 0. Okay, so this becomes the only non-zero. Where I shouldn't have said there's also acceleration in the z direction. Acceleration in the z direction is z double dot, and for z we have so z dot is negative 0.5, z double dot is 0. Okay, 0. So we take the 3 equations from before, never finished this though. So I have 1.5 times 0.7 squared equals, in with the minus in front, so negative 0.735 meters per second. This is the non-zero one, this is 0, this is 0. Okay, so this is 0, this is 0, this is I still have it, negative, and the boy is 40 kilograms. I'm multiplying by 40, and I have negative 29.4 meters per, no, nothing, that's newtons. So here we have newtons as units. Okay, so back to, to continue, we take these equations and say I have reaction in the r direction. It's going to be and it's the only one in the r direction. Okay, it's negative 29.4 newtons. Reaction in the theta direction, it's by itself, there's no other component, and that's going to be 0. And then lastly, for the z-axis, I have negative mass of the boy, that's 40 times 9.81, and then I have plus reaction in the z direction equals 0. Okay, so react from here, I get reaction in the z direction is a positive value, and it's pointing up. So I have 40 times 9.81. So 40 times 9.81 equals, so it's 392.4 newtons. Okay, so answers are radial direction 29.4, and it's towards the axis of the helix of the slide. In the transverse direction, I don't have a reaction, and in the z direction I have essentially the we're resisting the weight of the boy. We can calculate the magnitude of the 3 components. You square this, sum them, and take the square root, and that will be the magnitude of the reaction of the result. All right, so this was it. moving it centered, and I